Let's continue the adventure of the AMPduino project. And if you're watching this video right now and you haven't watched part 1, I suggest that you watch part 1 so that you will understand the very basic of Arduino and the AMPduino project, especially on enabling your sketch IDE, how to connect your Arduino. This one in here right now, I would say the Arduino project. I really suggest you watch this video. And in this video, what we are going to do is to make a little bit of the coding modification by modifying the turning on the LED and turning off the LED. And at the end of this video, we should be able to do a kind of qualification. What is the timing of the delays, by measuring that with an oscilloscope, especially at 20 milliseconds. And we're going to enable this system, I would say system, the Arduino system, to power on and power off, like a power on and power off the amplifier. That's what we are going to do in this video. So without further things to do, let's dive to that. And what we can do is to do a kind of experiment in here, wherein you can actually change the speed or the rate of blinking by changing the delay from 1000 millisecond to about 500 millisecond, or that is equivalent to about um, 0.5 seconds. So let's do that. Just click this upload button or download button, and then it will compile and then download it immediately if there is no issue. And then you can see the rate of the LED right now. It is blinking fast, 0.5 second, I should say, or 500 millisecond. Now I can go deeper into a faster flashing rate by going into, let me jump to about 20 millisecond. So I can change that one to 20 millisecond and then download that. And there you go, very, very fast, as you can see in here. I'm not so sure if my camera can able to capture that one. Let me focus it. And there you go, flashing very fast. That is a kind of a small changes on the program to change the flash rate of the built-in LED. And that's how you basically do the programming, by changing the time to make it shorter, to make it longer. Let's say 2 seconds. And then you can actually see every 2 seconds the LED blinks. There you go. 2 seconds, the LED blinks. That's how easy it is. Easy as 1, 2, 3. What I'm doing it right now is do something that maybe other Arduino lovers never done that before, and that is about understanding about the timing of the Arduino for 1 second, how precise it is. So I have here my Lotto. This is a PC-based oscilloscope, and I need an extra USB port. It's the setup in here using the OSCF4. Oh, I can see the mouse in there. No, not the mouse, the cat. Just disturb me. Oh my God, she's doing the thing. Oh my God, she's doing the thing. Anyway, never mind. That's her business. So going back in here, this is the Arduino Uno. This is the GND, and this is the black connected to the ground of the oscilloscope. And this is the pin tuning in here. Pin tuning is just over there, and pin tuning is connected to the yellow cables and connected to the positive of the oscilloscope, and then input to channel A. And there you go, about to open the interface. And there you are, you can see this is the LED on. Now that is the LED on, LED off, LED on, LED off, LED on, LED off. Let me do that into the white background. And and I'm going to invoke the cursor right now. So let me put the A cursor into the plus, going to turn on the LED, and then that will give me about from A to B. So this give me about 1.047 seconds. So basically it's the signal for the Arduino is accurate. So 1.047 seconds. Na, nya. Hmm. Kakararag na ka na na. Hmm. Kaya po, Piman. Almost finished in here, but I still like to change the time to about let's just say 50 millisecond. 50.456 milliseconds. Pretty close, or I should say it's exactly 50 milliseconds. About 20 milliseconds. Yes, it does changes to 20 milliseconds. So there you go, 20.329. This is 20 milliseconds. So there you go, 20 milliseconds, fast blinking here at the LED, and I can see clearly here at the OSCF4 oscilloscope. That's pretty cool, that's pretty cool. Success guys, success, success, and success. So with that experiment, confident that what we are writing in the Arduino sketch, the IDE, is exactly what is being outputted in the real world based on the LED and based on the OSCF4 captures. When I say 20 millisecond delay, 20 millisecond, it blinking fast on the Arduino Uno R3, but I cannot say this is 20 milliseconds. So I have to use the oscilloscope OSCF4 from Lotto Instrument, and it says 20 milliseconds. So the next thing for me to do now is to get off the oscilloscope, which I don't need it because I already proven it. Remove these connectors in here. So this shield is basically the one I'm talking about. They call it the A3CS, the Arduino audio amplifier controller suite, which is I designed specifically for this project. So how it works is that because as you can see that in Arduino Uno, I need to use this kind of special male connector to insert that into the female. But when I want to get some kind of standard connectors like what I've been here, so if I'm going to use this connector here, 4 connectors with a 2.5 mm pitch, I cannot just simply connect it like that. In order for me to make my life easier as a DIYer and a maker, I have to make use of a shield wherein I can simply put it this way. It's designed to interface with the Arduino Uno connector, R3. I would like to emphasize that again, it is R3. I never tried to use this one in the Arduino Uno R4, the minima or the maxima. That's why I'm stressing here R3. So it goes like that, and then click it, making sure it is fitted well without any gap in here. And then I designated all the connectors in here for me to easy plug and play. So this connector in here, this is for the LED. There is a switch in here, and inside there is an LED, and it is designated to be connected in here. There you go. And now I'm going to put the USB connector to power it up. And what I do, oh, this is about 50 millisecond. Right, 50 millisecond, it is blinking on the switch, 500 millisecond or 0.5 second. So it looks like things are getting perfect so far. The super basic of the Arduino Uno R3. So what we have done so far in this first episode of the programming is that we familiarize ourselves with the Arduino IDE, that's so-called Arduino Integrated Development Environment, simply called Sketch or Arduino Sketch. We try to load a program that kind of a blink LED example from Sketch, and then we understood what is all about the program. There are a few codes in there, like 1, 2, 3, 4, 5, like the pin mode, built-in LED, defining it to be an output. It is an output because it will drive the LED. Then it goes on to the void loop, where is the main program, wherein we write digital write the built-in LED into a high, into a low. Low means the LED is turned off, high means the LED is turned on, simply because the LED is connected into the current source configuration. When it is logic high, it is turn on, logic low, turn off. And then we play a little bit of the delay, and that delay can be changed to 1000 millisecond. 1000 millisecond means 1 second. 500 millisecond means 0.5 seconds. I try to use the oscilloscope OSCF4, which is a 4-channel virtual oscilloscope from Lotto, and then further go down to 20 milliseconds, and exactly that the oscilloscope can measure 20 milliseconds. But my eyes, at that rate, at that turn on, turn off at 20 milliseconds, I cannot really judge it. But the oscilloscope can do that. So all in all, everything is so far with the Arduino Uno alone. That's perfect. That's perfect. Then we go on to interface the A3CS shield, and then I'm going to make use of the power on off LED. That LED inside the power on off switch, and then blink it also into like 1 second, 500 milliseconds, into any rate that I'd like by changing the program, and it indeed perfectly as what I wrote in the instruction into a real-world response. So that's a little bit detail of the recap, and as I'm saying that I think that I have to go to program number 2 right now. But before that, I would like to thank each and every one of you who is watching my videos, wherever you are in this world. Thank you so much. Thank you so much. And for those aliens who is watching it right now, I have something for you. Just wait for it a little bit. I just wanted to finish this one. From here then, bye for now, and see you in the next video. Don't miss it, guys. Don't miss it. Stay tuned.